learn about the properties of atoms and the properties of matter. Atoms make up the smallest part of an element that retains its chemical properties. An atom consists of a nucleus, which is located in the center of an atom. It is a dense area that contains 98% of an atom's overall mass. And within the nucleus, you have your protons and neutrons. Your protons have a positive charge, and they determine the identity of an element, meaning that if you look at the atomic number, you're going to know the number of protons found in that atom. Finally, in the nucleus is our neutrons, which have a zero or neutral charge associated with them. If you add the neutrons to the protons, it helps you determine the mass of an atom. If you change the number of neutrons, you're going to create an isotope, and we'll talk about isotopes later. Outside of the nucleus are the electrons, so keep in mind these are not located in the nucleus, rather they orbit outside the nucleus. They have a negative charge, and they're also responsible for all chemical reactions or bonding between atoms by being added or removed, or shared I should say, and they almost have no mass. In a stable atom, the electrons are equal to the number of protons. This makes the atom have an overall neutral charge. So in math, if you take plus 1 minus 1, you get 0. 0 meaning neutral in our when we talk about atomic charges. Here's a really good example. In this atom, if we count up our electrons, and if you see they're located outside the nucleus, here's our nucleus here, we have 1, 2, 3, 4, 5, and 6 electrons, meaning we have 6 negative charges. Inside the nucleus are our protons and neutrons. If we count our protons, we have 1, 2, 3, 4, 5, 6. So we have 6 positive charges. Again, if you take negative 6 and you add 6, you're going to get 0. So this atom has an overall neutral charge to it, meaning it's not positive or negative, it's neutral. This is a stable atom. Here's a really good video that describes the properties of atoms.
Dear Tim and Moby, what in the world are atoms? From Chris. What in the world isn't an atom? Air, water, pants, leaves, robots, and humans are all made up of atoms. This is the periodic table of elements, and when you take chemistry, it becomes your best friend. This chart shows and predicts every known element in the universe: oxygen, iron, lead, and so on. These elements are all made of atoms. Around 2,400 years ago, a Greek guy named Democritus argued that everything in the world was made up of particles so small they could not be cut in half. He called these tiny things atoms, from the Greek word atomos, which means indivisible. In the 1800s, another guy named John Dalton refined the idea with his theory that atoms are the smallest particle of an element that retains its chemical properties. That means if you break apart an atom of an element like carbon, it's not carbon anymore. What is it? Well, atoms are made up of even tinier subatomic particles called protons, neutrons, and electrons. The atom's center, or nucleus, is a cluster of protons and neutrons. Protons have a positive electrical charge, and neutrons have no electrical charge. The atom's nucleus is held together by the strong force, which keeps the positively charged protons from repelling each other. The nucleus is surrounded by a cloud of electrons moving near the speed of light. The electrons have a negative charge that attracts them to the protons, and they live in shells representing different energy levels. On the periodic table, atoms are organized by their atomic number, which is really their number of protons, or electrons. You can also find the atomic mass here, as well as the element's symbol. I kind of think it's amazing that the difference of a few protons, electrons, and neutrons can produce such a variety of elements with completely different properties. Different types of atoms can bond together to make molecules. Water is a molecule. It's 2 atoms of hydrogen and 1 atom of oxygen, or H2O for short. You would not believe how small atoms are. It would take nearly 10 billion atoms just to cross this dot. And the scale of the atom itself is even more ridiculous. all matter in the universe is mostly made up of empty space, which frankly blows my mind.
So now that we've talked about atoms, let's look at molecules. Molecules are made up of atoms, and molecules are the smallest unit of a compound that retains the chemical characteristics of that compound. So for example, there's a water molecule. The water molecule is made up of 2 hydrogen and an oxygen. And the hydrogen and oxygen come together through chemical bonds. And these are forces that hold atoms together through sharing or exchanging of electrons. In covalent bonds, we see these form between 2 nonmetals. The atoms share electrons to form molecules. And then in ionic bonds, we tend to see these between metals and nonmetals. And in this transfer of electrons, we form a cation, which has a positive charge, and positive charge forms on the metals, and these generally lose electrons. And then we also have anions, which have a negative charge, and these form on the nonmetals, and these are the ones that gain electrons. And when 2 elements come together through an ionic bond, we form an ionic solid, which can have very strong attractions. An example would be table salt. The atom chlorine steals an electron from sodium. The chloride ion is negatively charged because it added 1 more electron, while the sodium ion turns positive because it lost an electron. Here's another really good video that describes these chemical bonds.
Hold on. Dear Tim and Moby, how do hydrogen and oxygen stick together to make water? Atomic glue or something? From Tabitha. Actually, she's not that far off. Atoms do tend to stick together, almost as if they were glued. If they didn't, there wouldn't be any visible stuff. Just a bunch of microscopic atoms floating around by themselves. Whoa. But atoms like to stick together, and the reason has to do with what's inside them. Atoms are made up of 3 basic particles: positively charged protons, negatively charged electrons, and neutrons, which have no charge. Protons and neutrons clump together in the center of an atom, forming its nucleus. Electrons whiz around the nucleus at different distances, which we call shells. Oh, they don't actually orbit in perfect circles like that. This is just a simplified model. In reality, they fly around randomly in a roughly spherical orbit called a cloud. But in any case, each shell can hold a certain number of electrons. The first shell, closest to the nucleus, can hold 2. The second shell can hold 8 electrons, while the third shell can hold 18, and the fourth shell can hold 32. And this is where things get sticky. Sticky. Well, when an atom's outermost shell is completely full, the atom is said to be stable. In other words, it generally won't react with other atoms. But when its outermost shell isn't full, an atom is unstable. It'll try to react with other atoms or molecules, so it can have a full outer shell. Take water. It's made of 2 hydrogen atoms and 1 oxygen atom. As you can see, hydrogen has 1 electron in its outermost shell. It would love to have 1 more, since 2 electrons would fill that shell up. Oxygen has 6 electrons in its outer shell. Since the second shell can hold 8 electrons, oxygen is looking for 2 more. So, oxygen shares a pair of electrons with 1 hydrogen, and another pair of electrons with another hydrogen. Now all 3 atoms are stable and happy. Yay! This sharing of electron pairs is called a covalent bond. Nope, that's not the only way atoms stick together. Ionic bonds happen when 1 atom takes an electron from another. Yoinkers! The extra electron gives the first atom a negative charge. and the other atom becomes positively charged since it lost an electron. In other words, they both become ions, atoms with electrical charges. And since opposite charges attract, they bond together. This is called electrostatic attraction. Sodium chloride, which is just table salt, is held together by ionic bonds. That's a good point. On their own, sodium and chlorine atoms have totally different properties than salt. Sodium is a soft metal that burns the skin and explodes on contact with water. And chlorine is a poisonous green gas. But when these two elements react, they form an ionic bond, and we get an edible crystal. Yep, covalent bonds can change an atom's properties too. Hydrogen and oxygen are both invisible and gases. But when they react, they form water, a very stable liquid. If you break that bond with a little electricity, you get hydrogen and oxygen gas again. No, wait! You know, every week it's the same thing. I teach you something cool, you shoot a laser beam out your finger, and I get in trouble. Well, not this time.